satellites, and wow, look at this. Afternoon, I'm up around 6 to 8 satellites. That's the value of GLONASS. And that's why some people are putting out GNSS receivers as opposed to GPS receivers, including the whole global navigation system that would be able to read both GLONASS and Navstar satellites to give you a position if you're in canyons or cities. And so the concept would be, here's both the GLONASS and the Navstar satellites plotted, and there's tons of availability there. Okay, a couple things else I can show. One of the things, so that cuts it back down to just the GPS satellite. One of the things I talked to you about was there's a hole in the sky on the north side. So you want to have your sun, your face to the sun as you're turning your GPS unit on and looking at it, so that the sun's not glaring onto the screen, but two, you're not blocking any satellites in the northern sky. So how do we see that? If we take a look at this, this is a map, and you can see that I put my 30-degree mask angle on here. I still have that on. This is a map of where the satellites are in the sky. Okay, that's to the north. This is east. This is south, and that's west. Of course, in the middle is what's called the zenith, or straight above you. This is my 60-degree line. That's my 30-degree line. You can see that I've got that 30-degree mask angle, so it doesn't have anything below 30 degrees. Now, I'm going to change that real quick just so you can see how that works. Sensation. Change that back to 10 degrees. Apply. Hit OK. This is all fun to play with. But you'll notice that I have a hole, I call it a hole, in the northern sky. Right here. There's no satellites directly north of me that's below 60 degrees. 60 degrees is a pretty big angle. So I can hold this thing face south, and my head's not blocking any satellites in the north sky. Okay. Why is that important? One has to do with eyelight, where you can orient yourself. The second one has to do with, and a lot of people don't look at this, but we have a problem with our horizontal accuracy is pretty good, right, with GPS. Our vertical accuracy is not very good with GPS. They say twice as bad or whatever. Why is that? Let me just throw something up here for you to think about. Why is our horizontal accuracy poorer than our vertical accuracy poorer than our horizontal accuracy? Well, here's the deal. If I have a satellite here, and I have a satellite here, and I'm here in the middle trying to figure out my position, I look at the pseudo range and I figure this out, and everybody draws these circles, and I do a pseudo range and I figure this out. And I have a little error bar in here, okay, where these things overlap within a certain area. Now, my error this way is much smaller than my error this way, right? I have these two circles coming together, and I don't know, I could be from here to here in terms of position, but only from there to there in terms of position. Okay, so we know that concept. Now, if we put something on the Earth, this is the Earth, and here I am, my little stick figure, and I'm standing here with my little GPS that has an antenna on it, and here are my satellites over here, here's my satellites over here, here's my satellites over here, but I don't have any satellites over here. So I can figure out my horizontal accuracy very well because my error position is relatively small. But because I have a satellite here, but nothing over down here, I can't get that same error from my satellite because I have no satellites below me. So that tells me that my horizontal accuracy is going to be better than my vertical accuracy because I got nothing below me to develop this. If I had a satellite here and a satellite here, I'd be able to hit this circle, then could look also like this if I just had those two circles. And so my vertical accuracy would be small, would be better. But I don't have that, and that's why the vertical accuracy is worse. Now, if we take that concept and apply it to here, north-south, there's actually an east dot and a west dot. So not only a H dot for horizontal, but how accurate am I in the east direction and the northern direction? Okay, so if I have satellites east and west of me, then my east dot is relatively small. But if I have satellites on the south of me, but nothing on the north of me, then my north dot is going to be higher than my east dot. Okay. Now, is that important? I don't know, but if I am parallel swathing a field, I think I'd want to go one direction better than the other direction because of that. Now, you guys are probably about the only other than 20 other people that know that concept of east dot and west dot. But the concept is if I've got no satellites on the north side, then my northern dot is going to be higher than my eastern dot. And that's just one concept. And why is there a hole in the northern sky? It's because if I go up here and I put my station not here, but at the North Pole, where my north is 90, right? And this is 0, right? I'm at the North Pole right now. I apply that and hit OK. This is what happens. If I'm at the North Pole, there's no satellites directly overhead. That's because my orbital plane is what, 55? Yeah, it's 55 degrees from if my head's the Earth, it's 55 degrees. So nothing goes over the North and the South Poles. Now, they get pretty good reception up there for DOT because they have satellites all around. They see a lot of satellites. They have nothing straight overhead. And that's why if I move south, this hole kind of starts to shift. So at 35 degrees, I still see that hole. But at 0 degrees, I don't see that hole. I don't think I do. Hang on. Because I'm so far south. Let's see we go. Yeah, here I am on the equator, so I don't see the hole.
Now you can't just have a satellite orbiting that way. It has to be sort of horizontal. Is that a technical thing, or is it just something to do with poles?
Well, they have them at 55 degrees. Now, could they run one over the North Pole? I would think so. I mean, they take pictures of the North Pole. They send, image satellites over the North Pole. I wouldn't see why you couldn't send it. But it's really not creating a problem because if I'm on the North Pole, hang on a minute, what am I doing? I didn't want to do that, but I want to do this. Station. And if I'm going to go back to the North Pole, apply. Okay, and I want to do this one right there. My satellite availability is pretty good. This is up to 10 on the North. I think I have my GLONASS still on. Nope, GLONASS not. So they're not on, but I'm seeing 9. There's a lot of satellites available to me on the North Pole. So there's really not a problem. Just that none are right overhead. If I have a fairly high mask angle, there's probably not going to be many at the North Pole. So if I throw this at 30 degrees, actually I'm going to throw it to 40. It might be a little bit more dramatic. 40. Okay. Yep. Yeah. Then the satellites available are fairly full, down to 3, because they're all sort of low on the horizon. Just a bunch of them.
And the mask angle is all around you.
Yeah, the mask angle would be if I can't see above or below 40 degrees all around me. And then you can change, you can cut out stuff, you can draw obstacles, all sorts of things in there if you want to. But I normally just work with mask angle. Now, the nice thing about working in a canyon is when I'm in a canyon, typically on a river, I can't see this way or that way, but I've got pretty good views this way, down the river side. And so I get satellites coming in from the side. One more thing that I want to talk about, last thing I want to talk about is, turn this off. I'm just going to turn all my satellites off. No, it's not the last thing. None. And turn one on, 4, and hit apply. Okay. And then I want to do, let's do this one right here. And it's kind of hard to see. I think I might go. Okay, so this is one satellite.